definition of a proportion and an example of how to solve a proportion. So a proportion is an equality of two ratios or two rates. It's basically just a fraction set equal to another fraction. So the proportion A over B equals C over D, with B and D not equal to 0, in other words, as long as the denominators are not 0, can be read as A is to B as C is to D. Here's an example of a proportion. We've got 4x minus 9 all over x equals 5 over 2, and we're asked to solve it. Proportions can be solved just like solving any old rational equation. You make sure all denominators are completely factored, write down any restrictions on the variable, and then multiply both sides of the equation by the least common denominator in order to clear fractions. So neither one of these denominators needs to be factored, and the only restriction on the variable that I see is that x is not allowed to be 0. Because if x were 0, this first fraction here would be undefined. So we can't allow 0 to be an answer. We'll make sure we make a note of that. The least common denominator among an x and a 2 would be 2x. So we need to multiply both sides of this proportion by 2x to begin. This will clear the fractions. I'm just showing that I'm multiplying both sides by 2x, just as we would do with any rational equation. On the left side then, the x cancels itself out, and we get 2 times 4x minus 9. 2 times 4x minus 9. On the right side, the 2's cancel each other out, and that gives us 5 times x, or 5x. So to finish solving the equation here, we've got to distribute the 2 through the parentheses on the left side. That'll be 8x minus 18 is equal to 5x. This is just a linear equation, so we need to collect the x terms on the same side. That means subtracting 8x from both sides here would do it. That gives us then negative 18 is equal to 5x subtract 8x is negative 3x. For the very last move then, if we divide both sides by negative 3, we'll have x isolated on the right side. So this therefore means that x is equal to negative 18 divided by negative 3 is 6. Okay. The last thing to do, as in any rational equation, is just to make sure that our answer is okay by comparing it to our restricted value. X was not allowed to equal 0. We didn't get 0. That means our answer is valid here. Our answer is a true solution. X equals 6. So there's an example of solving a proportion. All you have to do is solve it just like solving a regular old rational equation, multiply both sides by the least common denominator to clear the fractions, and then solve the resulting equation. You may have learned a technique in the past called cross-multiplying to solve a proportion, which means you just take the numerator of one ratio multiplied by the denominator of the other one, and set that equal to the numerator of the second ratio times the denominator of the first one. That technique works for solving proportions, but it only works for proportions. It doesn't work for rational equations in general that have more than one term on either side of the equation. So this technique that I've showed you works for all rational equations, including proportions.